couple more examples. I think we're going to have 2 more videos for this lesson. But for this particular one, what we're going to do is we're going to pull a marble out of a box. There's a blue marble in the box. There's a green marble in the box. And we have 3 boxes, 3 separate different ones. Because each box is different, each box is its own little thing, this will be an independent event. All right. All right, they don't rely on each other. If I pull a blue one out of this box doesn't care. It doesn't even know. As a matter of fact, these are inanimate objects. So what's the probability of choosing a blue marble from each box? Well, if I pull one out of this box, I have a 1 out of 2 chance. If I pull a blue one out of this, I have a 1 out of 2 chance. If I pull a blue one out of this, I have a 1 out of 2 chance. And I want to get each of those. So I want a blue one and means multiplication, a blue one and means multiplication, a blue one, so on and so forth. And I just do that math. 1 times 1 times 1 is 1. 2 times 2 is 4 times 2 is 8. And 1 divided by 8 will give us 0.125. No calculator needed for that one because I know my eighths. All right, that's roughly 12.5%, but this is the answer I'm looking for A. We move on to part B. What's the probability of choosing a blue marble, then a green marble, then a blue marble? In this case, the odds, it seems like a little tricky here, but I have a 1 out of 2 chance of getting a blue marble times the green one doesn't have any different. It's still 1 out of 2, even though it's green. It's still a 1 out of 2 chance. And then another blue one, it would still be a 1 out of 2 chance for that one. So if I multiply those together, I'm still going to get 1 times 1 times 1, which is 1, 2 times 2 times 2, which is 8. And then I still end up with that 0.125. It doesn't change. It's the same. And the reason why is because the odds of getting a green one and a blue one aren't any different. And then on the last one, what's the probability of choosing at least one blue marble? Well, that's work. It's actually kind of tough to do just on its own. So really what you want to think of on this one is, what's the complement? What would be the opposite of this? So the opposite of getting at least one blue one would be the probability of getting all green. Well, we already know the probability of getting all green. It would be the same as the probability of getting all blue. It would be 0.125. So the probability of at least one blue one would be 1 minus 0.125. And that's going to give us 0.875, 0.875. All right. So once again, for this part C right here, you're going to do a complement. This is where you are doing the opposite. So all green ones would be the opposite of getting at least one blue one. Because if I got 2 blue ones or 3 blue ones or only 1 blue one, the opposite of that would be getting all green ones. So I just did 1 minus the 0.125. And we're ready to rock in that regard. Okay, we'll move on to the next example. We're going to do some probabilities now, favorable over total, looking at some dependent events, I believe. So let's get to it.